Hello guys, welcome back to another video. Today we're going to be looking at a very interesting problem, as you can see right here. It's a pretty beefy equation, but I think we can take the derivative. It's pretty doable. So immediately we have x to the x times sine of x to the x times cosine of x to the x times tangent of x to the x. We're trying to find y prime, where this is the derivative. So immediately, the first thing you have to notice is that this is in the form of two functions being multiplied, x to the x and this large term. So when we take y is equal to fg, where f and g are functions, y prime is equal to f prime g plus g prime f, where prime is the derivative. And then we'll apply chain rule to see how this works. Chain rule, if you don't remember, is dy dx is equal to dy du du dx. So you differentiate with respect to another variable, and then you differentiate that with respect to x. So you will ultimately get dy dx. And we'll see that in action. So let's get right into it. First off, I'm going to be writing y prime is equal to the derivative of this, f prime g. Remember, f prime times g plus g prime f. Now, what is the derivative of x to the x? We did this earlier in one of my previous videos, and you can check that out. But in summary, a quick shortcut of doing this. I know if it was wrong, but we're gonna try it. Let's write y is equal to x to the x here in red. Well, let's treat this number up top like it's a constant. So imagine that's x squared. What would we do if y equals x squared? Y prime would be 2x. And we subtract 1 here, so it just becomes 2x, like that. But what if, instead of treating that like a constant in the exponent, we instead thought it was y is equal to 2 to the x? What is y prime then? Y prime would be 2 to the x ln 2. And that's a separate proof, but yeah, I'm sure you know that. It would be 2 to the x times ln of 2. So all we have to do to find this derivative, in fact, is just combine these two rules, and we'll see what that means. It's just a quick shortcut, and by all means, you can do the proper logarithmic differentiation. But if we have y equals x to the x, y prime is first this. We treat this like a number, so imagine this is something. We just do x times x to the x minus 1, and then we add, if we were to treat this x right here as a number, then we add x to the x ln of x. Let's simplify this a little bit. That means y prime is equal to, what is this? This is x to the power of 1 times x to the x minus 1. This 1 and 1 cancel because exponents add when we're multiplying with the same base. So we have y prime equals x to the x, and then we have this right here, plus x to the x ln x. For simplicity purposes, I'll just be factoring out an x to the x right here. So we have y prime equals x to the x, 1 plus ln x. That's our answer. And I did the proper proof of this using the proper logarithmic differentiation in my separate video. You can check that out. So now we know that the derivative of, I'll write this right here, the derivative of x to the x is equal to x to the x times 1 plus ln x. So that's something we need to know for this question. Now moving forward, let me erase all this. So we got that much done. So what do we have so far? Now y prime is equal to f prime g. So our f prime we said was that, so let's write that. We have in red x to the x, 1 plus ln x. And we're multiplying by g again, so we have to multiply by this large function g. We just repeat it as it is. Sine of x to the x, cosine of x to the x, tangent of x to the x, parentheses like that. Now we have to do plus g prime f. And this is where the fun part begins. Differentiating this monstrosity of a function right here. Let's get right into it. So I'll write for simplicity ddx of parentheses sine of x to the x, cosine of x to the x, tangent of x to the x, parentheses, times our other function f right here, times x to the x. So now, for simplicity, I'm not going to be rewriting all of this stuff, so we're just going to find this derivative right now. So ddx of, I'll just call this entire function, this function f for now, okay? So d dx of f is equal to what? First off, when differentiating this monstrosity, we want to completely ignore what is on the inside, and this is for chain rule, and you will see this in action in just a moment. So imagine this blue blob, we call that u. We're going to differentiate, instead of f here, I'll just write sine of u. And the derivative of sine of u is actually equal to cosine of u. Are we done? No. Times the derivative of u, just like that. So if we just write this how we did earlier, let's write it like that. Now I'm going to remove that blue line I put earlier, and then I'm going to clarify everything. So if I move this over here, we have this rule established. So what does that mean for us? Let me clear things up. And that means this entire derivative is indeed equal to cosine of this big blob right here, x to the x, x to the x cosine of x to the x tangent of x to the x, just like that, multiplied by the derivative of this. So multiplied by the derivative of x to the x cosine x to the x tangent x to the x, just like that. So how do we find this? Let's just repeat the process. Now how do we find that? That's going to be a little bit of monstrosity as well. Once again, we have another function, f, and this is g, so let's apply our product rule again. What's the derivative of x to the x? That was x to the x times 1 plus ln x. And then the product rule, it says that if y equals fg, y prime equals f prime g plus g prime f, just like that. So this is f prime, then we have to do g, which is this thing, g, so cosine of x to the x tangent x to the x, close, plus g prime, which is, and we'll get there in 1 sec, and let me just write the f. The f here was x to the x, so x to the x, and then g prime is what now we have to differentiate. So times the derivative of cosine of x to the x tangent of x to the x. And we'll unravel all of this, it'll all make more sense. So we got this much now. Now all we have to do is just find this. And once we find this, we can plug it back in and get our result. Now what is the derivative of cosine of x to the x tangent of x to the x? Let's see. Once again, we treat this entire thing in this middle, or the argument of the cosine, as a u and differentiate. So d dx of cosine of u is indeed equal to negative sine u times d dx of u. That's chain rule. So we can write this as negative sine of x to the x tangent x to the x, like that, multiplied by d dx of x to the x tangent x to the x. While going in now, once we find this, we'll essentially be done. D dx of x to the x tangent x to the x, so many x to the x's, wow, is equal to this. We once again have our f and our g. So we have f prime, which we said was x to the x times 1 plus ln x, g, tangent of x to the x, plus g prime, which is, we'll get there in a second, we have g prime f. G prime, we'll write that, but I'll just write f first. We have x to the x, and then g prime is d dx, tangent of x to the x. And finally, once we find this one, we'll finally be done with our chain rule. D dx of tangent of x to the x is equal to what? We treat this like a blob, once again. The derivative of tangent of x, or tangent of u, I should say, is equal to secant squared of u times d dx of u. And I can do a separate proof on that if you guys want later. Let me know in the comments. So this is equal to, we have secant squared of x to the x times the derivative of x to the x, which is x to the x, 1 plus ln x. Now, essentially, we're done. But now we have to combine all of our answers. So let's backtrack everything. I drew this arrow here saying that the derivative of x to the x times tangent of x to the x is equal to this thing, all of this. And then you see how I wrote d dx of tangent of x to the x. What did we say that was? This is the derivative of tangent of x to the x. So I can essentially just take this and plug it in right here. I can just take this definition and plug it in right there. And that would be correct. Now what do we do? Now we said that the derivative of x to the x tangent of x to the x is this entire thing. And what do we need that for? We needed that for right there, because we just put out d dx of x to the x tangent of x to the x. So now I can essentially take this entire thing and just plug it in for right here. Let me erase this. Let me just replace all this so that you can see that we indeed have. But the key thing to remember here is that we get our parentheses right, just like that. Let's see if we did that earlier. Did we miss any parentheses? I don't believe we did. Nope, everything looks good. Okay, let me redo. But here, we have to pay attention since we're multiplying by the derivative, that little dot here, and we're adding terms, we have to add parentheses like that. So this gives us the answer of the d dx of cosine of x to the x tangent of x to the x. And what do we need that for? We needed that for right there. So we can essentially take this entire thing, this entire monstrosity, and just plug it in. A lot of moving around. So I'll just do this. And we have to get our parentheses right, otherwise that'll mess other things up. And I'll put this in here. I'll put this here, right here, this right here, and this right here. And that gave us, ladies and gentlemen, I will erase this. That gives us the answer of what is d dx of x to the x cosine of x to the x tangent of x to the x, which is this giant thing right here. So that means we can just replace this. So you see how the answer gets bigger and bigger and bigger, and we're almost done actually. So instead of all that, I can just take this and just put that right there and just draw parenthesis here, parenthesis here. And now lastly, that gave us the answer of the derivative of sine of x to the x, cosine of x to the x, tangent of x to the x, that thing. So all we have to do is just plug that back in and we have our answer. So I can just take, I can just take this and I can replace it with all of this. And instead of drawing, I'll just draw a big bracket. That's a weird bracket. I'll put the x to the x right here, and then a big bracket right there. So that means we have no other derivatives to calculate in this entire answer. And if you want, I'll rewrite this in a little bit of a cleaner format without all of our dots and brackets and all that, so it's easier to see. I'll move this out of the way. So ladies and gentlemen, that means y prime is indeed equal to x to the x times 1 plus ln of x sine of x to the x cosine of x to the x tangent of x to the x, parenthesis, 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 plus cosine of x, I'll put the x to the x in the beginning. I'll put this x to the x in every term, plus x to the x cosine of x to the x cosine of x to the x tangent of x to the x, and then multiplied by x to the x 1 plus ln x cosine of x to the x tangent of x to the x plus x to the x, or actually, sorry. Oh, yeah. Yeah, that's right, actually. X to the x, negative sine of x to the x. Am I missing anything? Let's see, did I miss something here? Possibly so. Actually, I don't think so. I think we're all right because I was just trying to distribute this, but when I distribute it, these are all multiplying. This is cosine here, and this entire parenthesis is multiplying with this. So I just need that 1x to the x right here, and I'll be fine. So I can continue. Then I have negative sine of x to the x, tangent of x to the x, parenthesis, multiplied by x to the x, 1 plus ln x, close tangent x to the x, plus x to the x secant squared x to the x, x to the x, 1 plus ln of x, close, 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 close. And ladies and gentlemen, that gives us our answer of our essential question right up here. The derivative of x to the x, sine of x to the x, cosine of x to the x, tangent of x to the x. Wow. I hope you enjoyed this video. Let me know if I made any errors or if you have any questions, and I'll let you know. Thank you guys. See ya.